Okay, so really quick, something I talked about at the end of the last episode I made a mistake on. So I thought that these lines were going 3/4 of the way down and then like there was one coming from the bottom and crossing over. That's not the case. The line we looked at, the 9438 97 one, that starts up here at 97 according to these coordinates, but obviously we've shifted they're the coordinates in the image, not the coordinates on my actual screen. So in reality the line, if you look at the coordinates, is 400 long. Sorry, you can't actually see these. So this line right here, this line's actually 400 long. Obviously it goes from 7 to 430, so 430 long. Now if we look at the coordinates and start at where the start of the line is, which is right here, and then we add 430 to it, so we go to 600 in the y, you'll see 600 in the y takes us to there, and that's like 430 more, so it is actually that line, and going the full length. Now the other line that's in that x sort of range coordinate sort of thing, is the other 91, so 92 down here. So as I expected, there's the left side of the line, the right side of the line. So yeah, it's working as expected. There's 12 outputs here, and I was expecting 6 lines, so I was expecting 12 outputs, because you get 2 for every line. And what we're going to look at this episode is how to get rid of the extra ones that we don't want. So I've actually already done this, but I accidentally did it off screen, so the code's already typed up. I'm just going to talk through it this episode, and explain where it all comes from. So let's get on with that. Okay, so don't need print lines anymore, get rid of that. And now the next step is right here. So from here down, I'm just going to quickly explain this. So black image, what this is going to do is return a black image. It's going to do that by creating a numpy matrix, well, a numpy array, sorry, full of zeros like the image, so in the same shape as the image, like the same size. So if we printed black image here, I'll do it so you can see. Oops. So if we print black image, you'll see it's just a huge matrix of zeros. These dots mean there's like stuff missing, so yeah. So we've got black image. Now once we've got black image, we're going to draw the lines on it. This is just for the sake of showing you like where the lines actually are, rather than just seeing the coordinates. So for line in lines, because lines is our array of where the lines are, coords equals line 0, so this is going to be the firstth element. So if we print, actually I'll scroll up. So we've got the line, so line 0 is going to be this right here. This is line 0, this is the firstth element of the array. So it's going to take that and set that equal to coords. So coords now has 4 values. Now cv2.line draws a line between, basically you do cv2.line and then you pass in like x1, y1, x2, y2. You don't quite pass them like that, you do something like this, and like pair them off. So yeah, it'll look something like that. And it draws a line from x1, y1 to x2, y2. You're probably all familiar with that equation. So what we're going to pass in for x1 and x2, x1 and y1 are coords 0 and coords 1. This is going to be the 0th element of the coords array, which is 1, 7, and 6. Then the firstth element, which is 4, 3, 8. So these numbers go in here. And coords 2, coords 3. Obviously that's going to then draw this line, and because it's like inside this for loop and whatnot, that's going to do that for every line in the matrix, in the array, sorry. This argument here, this one right here, is the colour, so we're going to make it green. 0 red, 255 green, and 0 blue, so just a full green line. This here is the width of the line in pixels, so it's going to be 1 width, because I want to show you that there's the double lines that are there. Then we do cv2.imshow, we're going to show the black image, but this time it will be black, it'll have the lines on. Then wait key. So if we save that and run that, you should see, there we go, we've got our black image with our green lines on, and you can see they're all sort of in line with where the lines are, and they're about the same length as well, as you can see here. And you can see there are definitely double lines, so we're detecting two, like the left and right side of every single line. So don't need these anymore, we don't need to visualize the lines anymore, so I'm just going to comment this out for now. Might delete this later, but I think it's quite handy to keep there, because if we ever need to see the lines, if something's gone wrong in the code, say on a different size board or whatever, we could see that. Actually, I'll check a different size board now and just check it works. Check the biggest one, because I would imagine this is going to be the hardest one for it to check. So uncomment this, save, run, and you can see, yeah, I expected this on some boards. See how this line here has only got one line detected, so you can see, like, if we line these up, it's detecting two for every line except this first one, which is going to cause problems. So this is why we're going to filter out these double lines and make them all single lines, but it is still detecting at least one line for every line, which is really good. We can still get this to work, it's still useful. So if we comment this back out, we can move on to the next step. Whoops. So next what I did was I created a new list, which is going to be a list that we fill with the lines that we want to keep. So all the single lines, the important lines that we need to keep. Then we're going to loop through, and we're going to say for line 1 in lines. So this is going to take a line from lines. We're then going to take another line and call it line 2 from lines. So we're going to loop through the same array twice, finding two different lines. And then we're going to say if the 0th element of the 0th element of line 1, so bear in mind line 1's from lines, so we can look at lines and we can say, right, the 0th element of the 0th element, so it's going to be like this 176 here. So line 100 is going to be 176 for the first line 1. Hopefully this makes sense. I'm not doing too good a job explaining it, but you'll get the idea in a sec. So what this is going to do, it's going to take the x coordinate of the first line. Now line 200 is going to take the x coordinate of the second line. I don't know why I've got random spaces here, but let's get rid of those. So it's going to check if line 1's x coordinate is less than line 2's x coordinate. So basically if line 1 is more left than line 2, and line 1 plus the line tolerance, I forgot to mention this, I added a line tolerance variable here of 5. So what this is going to dictate is how many pixels a line's allowed to be close, like how many pixels a line has to be next to another line for it to be considered the same line. So this says that if a line's within 5 pixels, it is the same line as whatever, so it's going to like delete any that are within 5 pixels basically. So if line 1 is left of line 2, and line 1 plus the line tolerance, so line 1 plus 5 is now more right of line 2. So basically, if 5 pixels is all it takes to change this sign, which means that they're within 5 pixels of each other, then we're going to append line 1, so we're going to keep line 1. This obviously, we're not deleting line 2 here, because what we're checking is if the line's left, we're not, like, because of the way we've done it, basically we don't have to delete line 2. Just think of it like that. It might be hard to get your head around, but basically because we're going to loop through in order, we don't have to worry about picking lines up twice or whatever. You'll see in a sec when I print it out that it does definitely work. So we're going to append to this list all the lines. So if I print lines to keep, we should see a list of line 1. A list of lines 1, so like it'll be a list of 6 lines that satisfied this criteria. So if I comment out this a little bit for now, we'll talk about that in a sec. where am I showing this? Ah, there we go, I didn't save it, that was the problem. Okay, so if you look at this output right here, this is actually quite awkward to see on the screen, but you can see we've got an array here. This is line 1. Obviously the initial data was as an array, so you're expecting it to come back as an array. And we've got another array here, so we'll count the number of times it says array, so 1, 2, 3, 4. Why is it only finding 4? Let me rerun this, I think the screen might have been over it. Yeah, that's better. So we've got 1, 2, 3, 4, 5 and 6. So it's found 6 lines and it's saved them into a list as an array data type. So now we want to convert that array, like the list of arrays, into a single array. So that's what these 2 lines do. That's what this one line does, sorry, and then the print obviously just shows it. So this line right here just literally creates a numpy array from that list. And then we print it, so if I save that, run that, you'll see we get back to the original list. And now all these x coordinates you can see are significantly different. So if we drew this, I drag this over, so if we draw this here, whoops, so for lining lines to keep instead of lining lines, black image still the same, all the rest should still be the same, I would imagine. This should work. So yeah, there we go, we see that we've got 6 lines and there's no longer like the double line, so get rid of that issue. Then we can see still got the coordinates right here. So yeah, that's probably it for this video. It's still running quite long. We can now, obviously in the next video, look at returning this this list of lines and return the number. Obviously, I should probably add this at the bottom now actually. So we can now return, actually we'll do this next video, so that'll be it for this one. We've found the lines, made them single, so basically we've returned a grid, and yeah, that's it for now. I'll see you in the next one.